we're going to try to prove that n factorial is greater than n squared plus n for all n greater than or equal to 4. The technique we're going to use for this is proof by induction. So our base case here is n equals 4. So we're just going to check that this is true for n equals 4. Okay, because if it isn't, then this result obviously isn't true and we can stop trying to prove it. So 4 factorial is 4 times 3 times 2 times 1, which is 24, and then 4 squared plus 4 is equal to 16 plus 4, so that's 20. 24 is greater than 20, so that's good. That's a good start. Next step in a proof by induction is what we call our anchor step. And this is where we assume that for some n equals k, so some specific k, we have that this result is true. So we have that k factorial is greater than k squared plus k. And then what we do is we consider, so now this is our induction step, consider n equals k plus 1. And what we're going to try to do is, using the assumption that it's true for n equals k, we're going to try and prove that it is true also for n equals k plus 1. Okay, so what are we aiming for here? I'm going to write my target over here in a little box. So what we're aiming to show is, given this result here, we're looking to show that k plus 1 factorial is greater than k plus 1 squared plus k plus 1. So let's expand that right hand side out, and that's equal to k squared plus 2k plus 1 plus k plus 1 is equal to k squared plus 3k plus 2, and that's equal to k plus 2 k plus 1. So if we can show that k plus 1 factorial is greater than k plus 2 multiplied by k plus 1, then we've completed our proof. So let's consider what we have here. So we know that k plus 1 factorial is equal to k plus 1 times k factorial. And then because k plus 1's greater than 0, well, we know for a fact it's greater than 4 as well, this is greater than k plus 1 multiplied by k squared plus k. Okay, and that's because we're taking this assumption here. So k factorial is greater than k squared plus k, so we can substitute that in here. Now we're going to compare this to k plus 2, and what we're going to notice is that k squared is greater than k, because we're taking again a number greater than or equal to 4 and we're squaring it, so it's going to be larger than the original number. And then we're also going to compare k to 2, and k is greater than 2 because k is greater than or equal to 4. So if this is greater than k plus 2, well, that means that this whole thing is greater than, and sorry, I put an equal sign here, I didn't mean to put that, it's greater than k plus 1, k plus 2, and we're done.